Okay, now I don't have enough Danfosses out here for everyone, so if y'all kind of group up in teams of 2 and we'll run through this. Okay, you can see on step number 2 that, you know, it shows the frequency and what each drive is set to. We'll go ahead and we're going to set ours to 55.0. So use your up and down arrows until you go down to 55.0. When you do that, hit enter. P00 is going to come up on the display. Okay, the first parameter that we need to set is P01. So use the arrow up key and go to P01. Once you hit that, hit enter. Well, I'm going to tell you what each one of those means. You set that to, you'll see a lowercase d00, go to D01, and then hit enter. Now it's going to go back to the parameter list. What this parameter is just telling the drive that we are going to control it externally. We will be sending it signals through our controllers, our output cards, making it do what we want it to do. Okay, the next parameter is P10. So use your arrow up and go to P10. Hit enter. Okay, that's on 10.0. We want to go to 1.0. So go down to 1.0. And hit enter, and you'll be back to P10. That parameter is the acceleration time. So we want, in 1 second, we want that unit to go from sitting still or whatever it was doing up to the maximum speed that we're telling it to go. So we want it in 1 second to make that happen. Okay, we'll go to P11 and hit enter. Again, that's on 10.0. We want to go to 1.0. D, yeah, D 1.0. Okay, this parameter is the deceleration time. We want to stop the unit in a second as soon as we take the power off of it. So it should come to a stop within a second. Since the beginning, we have played around a little bit with that. We tried to stop it in a half a second. We were getting tripping on over voltage pretty regular. We tried some other things to rectify that problem, but now we're back at 1 second. It seems to work the best. So that's where we're at on that. The next parameter, if you're on D1, hit enter and get back to the parameters. Go up to P17. What that parameter is your slow speed. We run the drive motors at 2 different speeds, 30 being the slower one. In the very near future, we will actually have 3 speeds on the drive. Something we have done to the latest version, those of you've probably seen the service bulletin, we have gone to 14.2 on our program. The biggest change in that is that we are slowing down the gantry to slow speed regardless of whatever speed you're running down the track for the last 5 counts before it stops. So what that does is kind of steps it down, and it measures the vehicle extremely good now. I mean, no, we've been doing, working towards this for a while. They were talking to me about doing the 3 speeds, and I really wasn't for it. But now, the way that we are slowing down first, regardless of the other speed, I mean, right now you can draw a line on the track, and it will. I don't care what you're doing, rocker panel. I don't care. It'll stop within a 1/4 inch of that line you draw in there every time. I mean, it's dead on. It really made a big difference.
Will everything in manufacture now come out with this new version?
Absolutely. Absolutely. Now, even on like on these drives right here, we're running through and it's not real difficult to set these parameters. But a lot of times you may have a customer that's, you know, 3 hours away from you. He's a pretty good guy, you know, pretty knowledgeable on stuff. You think he can put this in, but you call me and say, hey, you know, could you set the parameters for me? I don't have a problem doing that at all. I do it. I usually set them anyway, you know.
Are these settings for every motor or just one of the drives?
Well, all of the settings we're setting right now in the parameters are the same on every motor. Now, P17, the one we set, I set it on all 3 drives, but you don't really have to. The only one we use it on is the drive motor. We try and make it easy, saying they're all the same with the exception of the frequency.
So you can set every single one of these damn faucets on these settings?
With the settings down below, yes, absolutely. Everyone leaves here and they're all set like that. Now, you may get a unit that if you're looking through on a brand new one, P11 may not be set to 1 on the boom motor. Because what I do, and I have to kind of take it on a case-by-case basis, it might be sucking the boom up too hard into the stops, you know, and it's pulling in too hard. You don't want it to do that because that'll wear on your gearbox. So what I do is I decrease the decel time, make it slow down a little bit quicker. 0.9 is pretty common now. We did have some problems going to that 50 to 1 initially, sucking it up too hard and actually wearing that spot on the gear, causing it to drop down, to drift a little bit, you know, drop down out of the cradle. To rectify that, sometimes we do go to 0.9 on the decel time on the boom. All right, we should be back on the P's. You want to go to P32. Hit enter, go to D01. What this parameter is for momentary power loss. Should you get a little blip in the power, incoming power coming in, we're telling the unit that we do want it to continue to operate when power is restored, but you're talking about something that just happens in a split second. If it stays down too long, it's gonna, you know, you're gonna run into another problem. You'll get a motor run too long code, and that's end up gonna shut it down anyway. So you're gonna have to reset it. Okay. For momentary power loss, that parameter is we're setting that, telling it that should we get a momentary power loss, we want the unit to continue to wash when power is restored. That's what that parameter is for. Okay, and enter, we'll go back to the P's and go up to P72. Okay, we're on P72, hit enter, and set that to D06. And what this parameter is the number of resets. When we send it a reset, if it trips, we can reset it up to 6 times before it will actually shut, trip out where you have to physically reset it. I think that's a good.
I wasn't making notes. Could you take a second and tell me what 01 and 10 and
Sure.
11 are again one more time?
Okay. Parameter P01 just tells it that we are going to be controlling it externally.
You mean normal operation?
All the small wires, the 18 gauge wires that we run, we're going to send it a signal into one of these terminals to tell it what to do. To tell it to go forward, to tell it to go in reverse, slow down, speed up. P10 is the acceleration time. P11 is deceleration. P17 is slow speed. P32 is momentary power loss. P72 is resets. Number of resets. Okay. Now the next parameter, there's not any more on here, but we're going to look at P73, 74, and 75. What these parameters are the 3 most recent fault, the record for the faults. 73 being the most recent, and so on. Right now, we don't really need to check them because they're all going to give you, it's going to give you a code. Now, in the manual, there is a list of what those codes mean. Like D02 would be over voltage, D04 is overload, there's overcurrent, ground fault, there's a big list of them, and it'll tell you what that is. This is very important to be able to troubleshoot the unit. Anytime any one of these drives trip, it's going to send a trip signal to our computer. Whenever that takes place, on the red line display, you're going to see an error message come up. You know, top boom motor tripped out. Well, at that point, you don't know why it tripped out. Is it an over voltage, over current, you know, ground fault? What is it? So then at that point, you have to go in and check those 3 parameters right there. And I would check all 3 of them because you want to see. If you see a D00, you know that at that point, it didn't trip. You may see it on, you know, 74 or 75. You know, hey, it tripped twice on over voltage. I do know that. Okay, now everybody go to P76. Okay, hit enter and go in there. Go to D10. Okay, now hit enter. You'll see that the drive will click, and then now F60.0 is on the display. What we have just done is wipe out everything that we had already set on here, and we went back to Danfoss factory defaults.
Sounds like a total reset.
Yeah, complete. Everything you did is gone from there. And the reason I show you that is because sometimes you may have somebody that was in there tinkering, and they may have set a parameter that we don't normally go in and set. And if the parameters aren't right, it won't operate right. So it's good to be able to do that. Now you're back at square one. You just go in and reprogram and see if that corrected your problem.
What was that P number again?
That 76? Oh, 10.
This sets it back to Danfoss.
Danfoss, no, that's right. Then you're going to have to reset our parameters. Now there's 125 parameters in this drive. Danfoss, their factory numbers work good for us with the exception of the ones that we change. So these are the only ones we have to set. And there's only 6 parameters and a frequency. In the manual, look in the Gantry section, and then there will be a Danfoss section in there. Now on the previous page, there's just a small schematic that only shows the wiring for the Danfoss. Just shows what 2 cards we're tying to, the OD08 and the ID08. We're going to be covering these Omron input and output cards. Now the common name, what we call all of these things, is after the dash. We call this an ID16. The one with the relays on it, we call it ROC16. That's just what we call them by. So makes it easier if you know what we call them. So when you call in for a part, you ask for the same thing. Right. But like on the older ones, they were SRT1 ID16. Well, Omron changed something internally, and it switched to a SRT2. But it's a direct swap. It's the same part. A little bit of difference in the circuitry. Okay, in front of all of you, there is different Omron input or output cards. All of these, again, are operated on 24-volt DC. If you flip the door up, it gives you kind of a map of the terminal strip of what goes where. Your BDH and BDL is your communication. That's going to be your black and your white. BS positive, BS negatives is your 24-volt DC. We use brown for positive, and we use blue for negative, and we hold that true throughout the unit. So every time you see a brown and blue wire, it's a DC. Right. Okay, depending on which one you have, they're either going to be under the smoked colored door. If you have one of these, it'll be behind this door. You'll see a row of dip switches in there. Do you not have one? There should be one for everybody. Okay, you've got one. Everybody got one?
Somebody stole that when they needed it on the watch.
Well, I mean, you've got that one there. If you open up that smoke colored cover, you'll see those dip switches. You'll see that on the switch itself, there are some numbers. You disregard those numbers. Those don't mean anything to us. You either look, if you've got one of these, it's on the outside of the small access door, is some numbers, and those are the ones we want to look at. On the other ones, it's right on the board itself. You'll see some numbers. At the bottom will be 1, then 2, then 4, then 8. What this is an address. The way this thing communicates to all these different cards is through an address. So depending on where it is, you'll set, you know, the address for the position that it's in. If you look in your packet, you'll find something that says outputs on the Water Wizard, Gantry. Three pages behind where we were a minute ago. Okay. This is also in a decal that is pasted inside of every cabinet door, whether it be for the pump stand on the main cabinet. You see that it has a decal there. There's also one in the gantry with all of the same information. If you look, it gives you the channel name, a description of where it is on the gantry or in the pump stand, you know, the ODOA, and then it has an address of 0. Then you look at the ROC 16, which is the one I have here, is an address of 2. If you have an address of 6, you would add the 4 and the 2 to make 6. You'd switch those to the right from the left to be on to make the address. Only when you install it, because whenever they
install one of these.
Right. Let's say you have to replace one, you know, look at the decal, see what the address is, and set it. Now, should you forget to set the address and you've already turned the unit on, and then you come back and set the address, well, it still doesn't know that you set it. So you have to reinitialize. You have to turn power off on the main panel, kill DC, and then boot it back up. And then at that point, it will find the address.
No, it says that the ID 16, this one here is address 0.
Right. That means you won't switch anything. All off.
They come set like that.
Now, all of the IDs and ODs that we have there are just going to be switching and receiving the DC power that you supply to it. If you have an ROC or a ZOC, which is this one right here, you actually have to supply it with what you want to switch. This ROC stands for Relay Output Card. So we can switch, you know, 24 AC, we can switch 110, whatever we put to the common terminals. And when you look at one installed, you'll see that we have jumpers. If you look at the numbers, you have a common of 0 that takes care of terminals 0 and 2, common of 2 for 4 and 6. We have to jump from common 0 to common 2 to make the connection, because you could put a different voltage to switch on a separate section of this card. Now on the gantry, we supply that with 24 volts AC. That's the only thing we're sending out of this, because that's what operates all the solenoids. No, that's just to get it off the DIN rail. Now on this relay output card, you'll see a little yellow little tool right there, and what this is to help you get those relays out. I'm not going to pull one out. Well, I'll go ahead and pull one out.
Now, there are spares on there, right?
Yeah, we don't use them in every, you know, there's one inside that panel and there's one inside this panel. We don't use every spot on them. So should you get a relay that you need to replace, you can just take one from a spot that we don't use.
How did you get that thing out of there?
What, this?
That's not.
No, that's not it. It's only on the ROC 16. You don't have relays on that. Now you use that to pull it out, but don't use it to put it back in, because once you snap it in, you're just going to pull it right back out. Just use your fingers. But if you're changing these, you can see that the prongs on that are extremely small. Very easy to bend one of those over. So you got to be real careful. Line it up and put it back in and gently push it into place. If it doesn't go right in, then you probably don't have it in line. Now you can buy these, but again, like if you look right there, we don't use 9 and 10. If you look at the channel 1100 right here, we don't use 9 and 10. If you needed a relay, you could pull one out of that position and pop it into where you need. It will send the signal, even if this relay's not in there. If I took it out of position number 7, the unit would still light that light. Just because the light's on does not mean that you're sending the power to to that terminal, because there could be something wrong with a contact inside of this relay. And this is what we call a ZOC 16. It's a 2-part controller. Here you still have to set the address. Now this isn't in the gantry. I'm just mentioning it because it's something that you're going to see. These relays are, you can see, much bigger. They take twice as many amps. This will handle up to 10 amps before it damages anything. The circuitry is a little bit different inside, so it's a lot tougher. I like it too, because you can just pop those babies off of there, no problem, put it right back in. Big terminals, you don't have to worry about bending them over. Now these relays here, we also use, again, this is all in the pump stand, but you've got a spot-free relay and your digital timer relay. If you need to rob one,
Spot-free relay, right?
Huh?
You can bypass that spot-free.
Why would you bypass it?
Just if you need to.
To do what?
If you need to.
Well, the problem is if you get a voltage problem sometimes, unless because you're on maybe you're on 2 different circuits or whatever. It's just I would always go through the relay. We have a terminal strip in the main panel. It says 2 for spot free. You got 2 pink wires. You bring your common from your 24 hot from your spot free into one terminal, and then you hook your signal wire, which is going to usually be number 10 on your spot free computer. You send the same voltage back into there, because the whole thing on the spot free is running on an AC voltage that it generates inside of its panel. If you send it AC voltage from my panel, sometimes there's a problem. So it's best just to keep them isolated. Use the relay. Okay, in front of you, you'll see some eyes. These are the telco eyes. We have 2 sets of eyes. Of these eyes on the gantry. You have a transmitter and a receiver in each set. They both wire back to a socket for the amplifier. The eyes, and when we get up again, I'll point them out on the machine. You have the ones that are about in the center of the gantry. Those measure the vehicle. Those actually measure the car. The ones in the cans out front are for nothing more than boom safety. Should the unit stop short, get off count, and those eyes are blocked, either set of eyes are blocked, and the boom will not come down. Now we measure the length of the vehicle in the first pass. After that count, it works with the counting procs, which I'll show you too when we get up again. Stores the length of that vehicle in memory, and it washes out the vehicle for the rest of the wash out of the memory. Now, you also have a set of banner eyes, which are the big yellow ones that you see. Now those eyes are for auto height. If the car is lower and does not block that beam, it will lower the boom 18 inches on washing passes. Now it measures the height of the vehicle on the first 2 passes. So it's going to measure it going down and coming back. And then after that, so you cannot auto height in any recipe sooner than the 3rd pass. Now, you'll notice on the banners there, you have a cable that you can screw on and off of there. On the Telcos, you do not. You have to wire them all the way, single run, don't splice them. I mean, you could in a pinch, if you had one in your truck that was this long, that would be the only time, and I wouldn't recommend doing it at all. Get a new one. You should, you know, once you start doing service work on these, you always need to have a set of these.
It's easy to run through that.
Well, the newer ones, we have changed the way we do the conduit. We have a dedicated conduit now that's just for the eyes. You have one of those cables and 2 of these that run across. It's pretty easy to make that pull, but when we were putting those same 3 wires with a 20 conductor running to the low pressure box, now it's almost impossible to pull. These wires are very small, it's easy to damage.
Too hard, it's
right. So I wouldn't recommend it. You know, try and pull it through there, but if you can't, then go out of one of the other, the SO cord fittings or something that you have some room, go through that fitting, and then tie wrap it. The insulation is heavy on this. Now the wires aren't very heavy, but it can withstand the chemicals, it can withstand the water without a problem. So if you're going to damage it putting it in, you're better off just to go ahead and securing it to the outside of the conduit and running it across. Now usually the ones on the short side, the ones on the same side as the cabinet, aren't that big of an issue. It's pretty easy to make a 3-foot, 4-foot pull. It's hard to pull 15 feet across that gantry, you know, with all the bends and everything that are in there. Okay, now the same cable that you hook to those banner eyes, we also use for the proxes. Now I don't have any, we've been using a Dow insulating grease, a dielectric grease for these proxes and the eyes. It is increasing the life of these proxes, I mean, noticeably. All you do is anytime you take this cable off, you just take the tube and you fill that whole void up with grease. When you put it on, some's going to come out, but that's okay because there's no more air in there. If it's full of grease, the water can't get in and damage your pins or short. So that is helping, and that's something that everybody should have on any of their service trucks. Have a couple of tubes of that. It's not, well, there's so many different ones out there. We asked the manufacturer of the prox what they recommend. They recommended it's a Dow number 4 insulating grease or something. So we use what they recommend to us. There is way too many to list of dielectric grease and insulating greases out there. You know, I'm not sure one works any better than the other, just as long as you're using something that can keep that water from getting inside of that connection. Okay, on some of these, some of them will only have 3 wires, some will have 4. On the gantry, every one we use doesn't need that 4th wire. It doesn't need the white wire with the application the way we're using it. On your treadle eyes and your entrance eyes out in the bay, we're looking for them to send the signal when they become blocked instead of sending the signal, you know, when they're blocked like we want to do on here. Right, so we use the white one in the entrance eyes and treadle eye application, but we use the black one on the gantry. On this comm cable, I didn't mention before, this is a shielded cable. Okay, that's to help prevent, you know, the trash coming in from your AC. This is another thing, you do not splice this wire because your shield is gone if you do that. If you need to, you rerun it. If you're down and you don't want to be down, you found the problem. If you start experiencing some weird problems, intermittent problems possibly, this is always suspect. take a good long look at it all the way throughout the boom and make sure you don't have any rub marks, or maybe watch it as it's going up and down the track and see if it's getting tight somewhere, because it could have become separated inside. If you needed to though, you could go get a 4-conductor shielded wire locally and just hardwire it in to get up and going. But if you're getting a weird problem, you've got to suspect the comm cable. Okay, in the unit, if it is a blower unit like this one is, you have another box up on top.